1, 2, 3, let's go!
Hey guys, it's me, Ashley, the math tutor. Welcome back to my channel. So I know I haven't uploaded in like months, and I want to say I am so sorry about that. I just got really busy and stuff like that, and I had to take care of like some other stuff, but I'm back, and I'm definitely going to be posting a lot more consistently, and I'm also going to try to be posting bi-weekly. So yeah, I'm going to try and post like every 2 weeks. Anyway, now that that's done, let's get into today's video. So in this unit, we are going to be talking about trigonometric integrals using substitution, or basically trig integrals with higher powers. So basically in this unit, we're going to work on integrals that look like this, like these basically. So we're going to work on integrals that look like this: sine x to the n power times cosine x to the n power dx. We're also going to work on the integral of tan x to the n power times secant x to the n power dx. Also, we're going to work on integrals that look like sine x to the n power dx, cosine x to the n power dx, tan x to the n power dx, and secant x to the n power dx. Also, all of the exponents, like all the powers, m and n and m and n and all of these, all the powers, they're going to be greater than or equal to 1. Usually greater than 1, but it could be equal to 1, but all the powers are going to be greater than or equal to 1. That's why I said higher powers and stuff. So for topic 1 of this unit, I'm going to be doing 3 videos on integrals that look like this: the integral of sine x to the m power times cosine x to the n power dx. Topic 2, I'm going to be doing 3 videos on integrals that look like this: the integral of tan x to the n power times secant x to the n power dx. And for topic 3, I'm going to do 2 videos on integrals that look like this, which are basically, they're basically the individual trigonometric integrals. So the integral of sine x to the n power dx, the integral of cosine x to the n power dx, the integral of tan x to the n power dx, and the integral of secant x to the n power dx. So like I said, for topic 1, we're going to do integrals that look like this: the integral of sine x to the n power times the integral of cosine x to the n power dx. I'm going to do 3 videos on this topic because there are 3 different scenarios for this type of integral. There are 3 scenarios. So there's a scenario where m, the exponent of the sine function, is odd, and n, the exponent of the cosine function, is even. There's also a scenario where m, the exponent for the sine function, is even, and n, the exponent for the cosine function, is odd. And there's also a scenario where m and n are both even, or m and n are both odd. So for topic 1, I'm going to make a video for each scenario. So here are some important things to remember for this video. I'm going to be bringing up things called equation 1 and equation 2, and I'm going to be bringing up things called rule 1 and rule 2. I'm going to be referring to them as rule number 1, rule number 2, equation number 1, equation number 2. So you guys might want to write this stuff down. So for equation 1, this is a trigonometric identity. Sine x squared is equal to 1 minus cosine x squared. And then also for equation 2, that I'm going to be, for what I'm going to be referring to equation 2 as for this video, is this: another trigonometric identity, which is cosine x squared is equal to 1 minus sine x squared. And then here's a couple like algebraic rules that are really important for this topic as well. So x to the power of a plus b, if a plus b was a number, right, that would be equal to x to the power of a times x to the power of b. Also, x to the power of a times x to the power of b is equal to x to the power of a plus b. Now, for rule number 2, x to the power of a and this whole thing, all of this to the power of b, is equal to x to the power of a times b. And also, x to the power of a times b is equal to x to the power of a, and all of this to the power of b. These are really important rules to remember. So I'm going to put them in the frame here, and then you guys can like pause the video to write them down and stuff. Okay, so before we continue, I'm going to do a little example of rule number 1 and rule number 2. So first off, I'm going to start off with rule number 1. Rule number 1. So let's say we were to do x to the 4th power times x to the 7th power. As you can see, these are two terms that are like have the same base, and then they're being multiplied by an exponent. For that, if it's two terms being multiplied with the same base being multiplied by each other, you can add the exponents. And also you multiply the coefficients, but here the coefficients are just 1 times 1, so that's going to be 1, so it'll just be still 1x, which is just x. So x to the 4th times x to the 7th, that's going to be x to the 4 plus 7, which is going to be equal to x to the 11th. Conversely, x to the 11th is also equal to x to the 4 plus 7, because x, oops, my bad. Let me rewrite that 4. X to the 11, and because 4 plus 7 is equal to 11, so x to the 11th power is equal to x to the 4 plus 7 power, which is also equal to x to the 4th times x to the 7th. Remember, we can, if it's an exponent like this, you can break it down into two numbers that it's equal to and also break it down this way. That's rule number 1. Now let me do an example of rule number 2. This is just algebra, but sometimes students I used to tutor, they used to forget this rule or get them confused. So I just want to like really lay it out for you guys. So for rule number 2, right? Say we were to have x to the 4th power and this whole term, all of this, to the 7th power. Here, if it's one term to a power and the whole, all of the terms to the powers to another power, you multiply the exponents. So x to the 4th to the 7th power would be equal to x to the 4 times 7, which is just equal to x to the 28th. Also, x to the 28th power, since 4 times 7 is equal to 28, this can be broken down into x to the power of 4 times 7, since 4 times 7 is equal to 28. And then this 4 times 7, if it's times, it can be broken down into x to the 4th and all of that to the 7th power. If the exponents are timed, it can be broken down like this. Yeah, here's an example of rule number 1 and number 2. If you guys wanted to pause real quick and write this down. It's just, algebra, but it's really important to remember. Okay, so let's do scenario 1. Like I said, scenario 1 is when m is odd and n is even. So we're going to do an example for that. We're going to do the integral of sine x to the 7th power times cosine x to the 8th power dx. So like I said, m, which is the exponent of the sine function, is 7, as you can see, and it's odd. And n is the exponent of the cosine function, which is 8, which is even. All right, so here on the left side, I'm going to put the steps that you do, and on the right side, I'm going to be putting the work shown. And also all of these papers and the work I'm doing, I'm going to upload it onto a Google Drive like document for you guys to see and like refer back to and stuff like that. All right, so let's get started. Okay, so let's start with step 1. Step 1, we're going to break off a power of sine x from the sine term. And when I say sine term, I mean the sine term in the integrand. This sine term. Break off a power of the sine x from the sine term. We're going to put it in the format of sine x to the something power times sine x to the power of 1, which is basically just sine x to the something power times sine x. And then we're going to rewrite the integral. So yeah, in this particular step, we're definitely going to be utilizing rule number 1. So yeah, that's why it's well, you guys will see, but yeah, that's why I really wanted to make sure you guys write it down. But anyway, so let's start. So the integral of sine x to the 7th times the integral of cosine x to the 8th dx. Now, we have to break off a power of sine x from the sine term, and we just want to break off one power. So we can do sine, we're going to take this term right here, and then, so sine x to the 7th power, right? That's the same thing as sine x to the power of 6 plus 1. Remember what we did in rule number 1, right? Remember 6 plus 1 is equal to 7, so we can break it down this way. And if it's in this format, sine x to the power of 6 plus 1 is the same thing as sine x to the 6th power times sine x to the 1 power. And this whole thing is sine x to the 6 times sine x to the 1. This is the same thing as sine x to the 6th times sine x. Yeah, so we utilized rule 1 here. And basically the reason why you have to break it down into 6 plus 1, because we're only breaking off a power of sine x, just one power. So whatever this is, whatever is here in the sine term, just do 1 plus a number less than that. It always has to be plus 1, whatever is here. So if this was like 9, it would be 8 plus 1. If this was 11, it would be 10 plus 1. It's always the number less than plus 1 that's going to be here, because we're only breaking off one power, only breaking off a power of sine x. Then we rewrite the integral. So if we rewrite the integral using this and replacing this with the sine x to the 7th, we replace it with this. To rewrite the integral, we would get the integral of sine x to the 6th times sine x times cosine x to the 8th dx. All right, so that's what we have right now. All right, now let's go to step 2. All right, and for step 2, I had a little bit of issues because I did a typo here. Then you tried to write over it with white out, but I'm sorry. It's kind of messy, but whatever. For step 2, we're going to rewrite the sine term. And when I say the sine term, I mean the sine term where the exponent does not equal 1, and rewrite it in the following format. Sine x squared and all of this to the power of something. We're going to find out this something, by the way. So you can skip this step if the particular sine term is already like this after you do step 1. And here's a little hint. 2 times the something that we find here, 2 times that something, should be equal to n minus 1. So like we said before, so in step 1, we established that we have sine x to the 6th power times sine x times cosine x to the 8th power dx, right? So using rule number 2, remember how for rule number 2, so like I said, with the sine term where the exponent is not equal 1 is this one, that's this sine term. So we're going to take this and we're going to break it down into, so sine x to the 6th, we needed to match this format, so it needs to be 2 times something. So that we need the exponents to be 2 times something. So since the exponent is 6 and 2 times 3 is equal to 6, we're going to break this down into the sine x of 2 times 3. And using rule number 2, we can break that down into sine x squared to the power of 3. So as you see here, our something is 3. So sine x to the 6th is equal to sine x squared and all of that to the power of 3. So now we're going to use this right here and we're going to replace this in the integral with the sine x to the 6th. We're going to write this instead. So we're going to write this instead when we rewrite the integral. So we're going to rewrite the integral as sine x squared to the 3rd power times sine x times cosine x to the 8th power dx. And remember my little hint, how I said 2 times the something should be equal to n minus 1. Here's the hint. It works, just to show you guys. The something we got was 3, right? 2 times 3 should be equal to m minus 1. M is the exponent of the sine function, which we already established was 7, right? So 2 times 3 should be equal to 7 minus 1, and then 2 times 3 is 6, 7 minus 1 is 6, so then 6 equals 6, so we're on the right track. All right. So anyway, this is so the hint is correct. So we're right. Anyway, this is the integral, how we rewrote it so far. So let's, using that, let's go down to step 3. All right. So for step 3, so like I said, for equation 1, recall in equation 1 that sine x squared is equal to 1 minus cosine x squared. Let me rewrite that x a little bit. Okay. Yeah, so it's equal to this. This is a trig identity. So what we're going to do is in the integral that we have so far, we're going to rewrite the integral and we're going to replace the sine x squared with 1 minus cosine x squared. So far what we have is we have the integral of sine x squared to the third power times sine x times cosine x to the 8th power dx. We're going to take this term and we're going to rewrite it. So since sine x squared is equal to 1 minus cosine x squared, this right here, we're going to replace this with 1 minus cosine x squared. So this is so since sine x squared is equal to 1 minus cosine x squared, we're going to rewrite, and we can also say sine x squared to the third power like this is also equal to 1 minus cosine x squared to the third power. So when we rewrite the integral, we would have the integral of 1 minus cosine x squared to the third power times sine x times cosine x to the 8th power dx. All right. Okay, so for step 4, we're going to rewrite the equation such that all of the cosine terms are on the left side of the integral and all of the sine terms are on the right side of the integral. This just helps with like the math later. It's just a helpful tidbit. If it's like this already, by the time you get here, you can skip this step. But yeah, so let me actually just write that really quickly. Skip step if it's already like this. If it's already like this. Okay, let me just write that really quick. So anyway, here we go. So far we got 1 minus cosine x squared. This is what we had from step 3 times sine x times cosine x to the 8th dx. So this has to be on the left, which it already is, but this also has to be on the left, and then this has to be on the right. And then we can just bring dx down. It's always last. So we're going to rewrite that as the integral of, oh, sorry, this is cubed. 1 minus cosine x squared cubed, my bad, y'all. Cubed. So, yeah, we're going to rewrite that as 1 minus cosine x squared cubed times cosine x to the 8th times sine x dx. This just pretty much helps with like the math later. Anyway, let's get to step 5. All right, for step 5, we're going to do a little u substitution. I think you guys remember that from Calc 1. But anyway, if you don't, I'll explain it to you as we go along. So for step 5, we're going to substitute using u. We're going to make u equal cosine x. Let me fix that equal sign. We're going to make u equal cosine x. And then next, we're going to take the derivative du over dx, and we're going to solve for du. So for the integral so far, right, what we have is the integral of 1 minus cosine x squared, all of that, cubed, times cosine x to the 8th, times sine x dx, right? So we're going to make, for this integral, we're going to make u equal cosine x, right? So now let's take the derivative with, let's take the derivative of the cosine x, take the derivative of u with respect to x. So du over dx would be the derivative of this, which is just the derivative of cosine x, which is negative sine x, right? So du over dx equals negative sine x. But we have to solve for this du right here. So du over dx is equal to negative sine x over 1, because anything over itself, anything over 1 is just, itself. And then we cross multiply because we're trying to solve for du. So what we get when we cross multiply is we get du times 1 is equal to negative sine x dx, which, anything times 1 is itself. So then du times 1 is equal to, oops, why did I do times 1 again? Sorry. It's equal to negative sine x dx, but du is equal to negative sine x dx. Okay, so that's step 5. Let's go on to step 6. All right, so step 6. Ooh, let me actually put step 6. I don't know why I forgot to write that. Anyways, let me put it down here so you guys can see into the camera. So for step 6, we're going to rewrite the answer from step 4 in terms of u and du. And rewriting it in terms of u is pretty easy. Let me put that u, make sure it looks nice. Rewriting it in terms of u is easy, but for du, it can get a little difficult. So to rewrite in terms of du, we just solve for sine x. So anyway, let's rewrite what we had from step 4, which was 1 minus cosine x squared to the 3rd power and times cosine x to the 8th power times sine x dx. Okay, so we're going to take each of these terms here, this term, and this term, and we're going to rewrite it in terms of u and du. So for blah, blah, blah. Sorry. So anyway, let's start off with this term. 1 minus cosine x squared and all of that to the 3rd power. So like I said, let me use a different color to illustrate what I mean. U equals cosine x, right? And then also du is equal to negative sine x dx. So for this term right here, 1 minus cosine x squared to the 3rd power, every time when we rewrite it in terms of u, every time we see cosine x, we're going to write u instead. So 1 minus cosine x squared and all of that to the 3rd power would be equal, since u equals cosine x, every time we see cosine x, we're going to put u instead. So I'll do 1 minus, and then I'll put a box here where cosine x was, and then I'll put u instead. Because remember, everywhere we see cosine x, we're going to put u instead. So then it was cosine x squared, so it's going to be u squared, and the whole thing was cubed. So then we'll do that cubed. So when we rewrite this term, 1 minus cosine x squared and all of that cubed, we rewrite it to 1 minus u squared and all of this cubed, because everywhere we see cosine x, we're going to put u, since u is equal to cosine x. So cosine x to the 8th, let's rewrite that term. All right, so we got cosine x to the 8th. Since u equals cosine x, when we rewrite that, we are going to put u every time we see cosine x, and then it was cosine x to the 8th, so now we got u to the 8th. And also the last term, which is sine x dx, the last term, we're going to take that and we're going to put that all the way down over here. So we're going to do that. So it was times negative sine x dx, right? Oh wait, no, du was equal. No, yeah, sorry. No, it was, sorry. Okay, yeah, I'm right. Never mind. Sorry. Ignore what I just said. Kind of had a little bit of a brain fart, but I'm still right. So it's sine x dx. Sorry, I meant du. When I said it was negative sine x dx, I meant du was negative sine x dx. Sorry. This right here is sine x dx, but du, when we did u and then we solved for the du after we did the derivative. We got negative sine x dx. But anyway, let's take that and rewrite it in terms of du. And like I said here, remember, to rewrite in terms of du, solve for sine x. So we're going to take sine x dx, and we have to rewrite this in terms of du. So since we already established that du is equal to negative sine x dx, let's take this equation and solve for sine x dx. So this is negative sine x dx. So to solve for sine x dx, just divide by that negative. Divide by negative 1, divide by negative 1. And then we get, then here we would get, this isn't really a fraction. This is just to, let me like take that out. I don't want people to think it's like a fraction. But anyway, to solve here, du divided by negative 1 is just negative du. And then here we would, the negatives cancel out, so we would just get sine x dx. So here we have negative du is equal to sine x dx. I meant to write that in red to emphasize my point for the substitution thing. So for sine x dx, for this term, since negative du equals meant to write that in black, sine x dx, we can rewrite that, we can write the sine x dx as negative du. Okay, so anyway, since we have that, let me get another piece of paper. I'm running out of space. So here's step 6 continued. Like we said before, originally we had 1 minus cosine x squared, all that cubed, times cosine x to the 8th times sine x dx, right? But since we already established here that this term right here, this term is equal to, well, we did u substitution. Let me put u substitution for this like row right here. But anyway, we already established that this term rewritten as u substitution would be 1 minus u squared, all of that cubed. And then we said this term would be u to the 8th. And we said this term would be negative du. We can rewrite this whole integral with using u substitution. We can rewrite it as 1 minus u squared cubed times u to the 8th times negative du. And then, you know, since this is like, you know, a negative du here, we can just take this negative out, and then we can just put it here as negative 1 times the integral of 1 minus u squared cubed times u to the 8th times du. So this is it that we have for step 6. All right, so let's keep going. All right, so for step 7, we're going to multiply all the terms out and then rewrite the equation. When I say multiply all the terms out, I mean all the terms in the integrand. So what we had so far was negative 1 times the integral of, that looks kind of ugly. I don't know. I'm so picky. I'm so particular. It's negative 1 times the integral of 1 minus u squared cubed times u to the 8th du. We're going to get back to the negative 1 later, but for now, let's just focus on the integrand right here. So we got 1 minus u squared, all of that cubed, times u to the 8th, and that's like the integrand. We're going to take like this and multiply all of that out, and then multiply that by u to the 8th to multiply all these terms out and get individual terms of u to the something plus u to the something minus u to the something, blah, blah, blah. Well, you guys will see it then. Sorry. Sometimes I feel like I talk so much, but I'm just trying to explain it, make sure you guys understand everything. But anyway, so first off with this, let's start off with this right here. 1 minus u squared and all of that to the third. Since it's to the third power, it's the same thing as 1 minus u squared times 1 minus u squared times 1 minus u squared, right? So we got to multiply all these terms out. So what I do if I have to multiply all these terms out, I just multiply the first two terms out, then bring the third term at the end. So let's do the first two terms right here, and then we'll do the third term at the end. So 1 minus u squared times 1 minus u squared. So we're just going to FOIL it. I presume you guys already know what that is. First, outer, inner, last for terms and stuff like that. For the terms. And yeah, so anyway, so first 1 times 1, that's 1. And then outer, 1 times negative u squared, that's negative u squared. Inner, negative u squared times 1, that's negative u squared. And then last, negative u squared times negative u squared is positive u to the fourth. And then so now we can take this term and then we can multiply it by, since this right here is equal to this right here, 1 minus u squared plus u to the fourth, we can take that and then multiply it by the third term down here, and then we can just multiply by the third term. Let me just write another like line just to show you guys. So anyway, 1 minus u squared plus u to the fourth times 1 minus u squared. To make math a little easier, since these are like terms, we can just say negative 1 minus 1 is negative 2. So 1 minus 2, it's supposed to be 2. 1 minus 2 u squared plus u to the fourth times 1 minus u squared. So let's just distribute it all out and just like kind of go from there. So then 1 times 1 is 1. Let me start over here because it's going to be long. 1 times 1 is 1. Negative 2 squared times 1 is negative 2 squared. 2u squared. Negative 2u squared times 1 is negative 2u squared. And then u to the fourth times 1 is just u to the fourth. Positive u to the fourth, that is. And then we also have to get this term as well. So then let's distribute again, but with this term. So 1 minus u squared, 1 times negative u squared is negative u squared. Negative 2u squared times negative u squared is positive 2u to the fourth. And then u to the fourth times negative u to the second. Now this is very important. This is where rule number 1 comes in, because so many students that I used to tutor, they would take u to the fourth times negative u to the second, and they would get negative u to the eighth. That's not true. It's negative u to the sixth, okay? Because it's two terms and their exponents are being multiplied, so you add the terms. So u to the fourth times negative u to the second is negative u, because positive times negative is negative. So negative u to the sixth. Remember that, because we're multiplying the two terms with exponents, so we add them. So anyway, I'm gonna rewrite this in terms of like terms, so that way it's easier to like simplify it. So I'm just gonna put it in terms of like terms. 1 minus 2u squared, there's another squared somewhere, this one, minus u squared plus u to the fourth plus 2u to the fourth minus u to the sixth, right? So then now we can kind of simplify it and stuff and add like terms. So we got 1 minus 3u squared plus 3u to the fourth minus u to the sixth. And let me check my notes really quick just to make sure I'm on the right track. Okay, yes, I'm correct. Okay, that's what I thought. Okay, good. Hopefully I edit that out the video. Well, maybe not, I don't know. Anyway, so yeah, so we take this. So as we can see, this right here, this is equal to 1 minus u squared cubed. All of this multiplied all the way out is this. So now, originally, like we had before, since we established that 1 minus u squared, all of that cubed, is equal to 1 minus 3u squared plus 3u to the 4th minus u to the 6th. What we can do is, now that we have all this, we can bring u to the 8th down and multiply that out to have, multiply that times all of these terms to have like the whole thing multiplied out. So now what we can do is 1 minus 3u squared plus 3u to the 4th minus u to the 6th times u to the 8th. Okay, so now let's multiply all this out. Let's just distribute it. So 1 minus u to the 8th is just u to the 8th. Negative 3u squared times u to the 8th is negative 3u to the 10th. 3u to the 4th times u to the 8th is positive 3u to the 12th. Remember, we're adding the exponents because it's two terms multiplied, so we add the exponents. Do not multiply them. Is rule number 1 if you want to look back in your notes. And then lastly, negative u to the 6th times u to the 8th would be negative u to the 14th. Okay, let me get another sheet of paper because I'm running out of paper. Okay, why is my AirPod over there? That is embarrassing. Sorry. So anyway, like I said before, so we had, when we multiplied everything out, we had u to the 8th minus 3u to the 10th plus 3u to the 12th minus u to the 14th, right? Which means that now, since we have established and we multiplied everything out, we can establish now that 1 minus u squared cubed times u to the 8th is equal to u to the 8th minus 3u to the 10th plus 3u to the 12th minus u to the 14th, right? This is what I mean when I say we were going to multiply all of the terms out and get the terms kind of like individual and just plus and minus and stuff like that. So since we established that this is what the integrand is all multiplied out, we can now rewrite the integral of negative 1 times 1 minus u squared, all that cubed, times u to the 8th du. We can rewrite that as negative 1 times the integral of u to the 8th minus 3u to the 10th plus 3u to the 12th minus u to the 14th du. That's what we can rewrite that as. All right, now let's go down to step 8. All right, so for step 8, what we're going to do is we're going to solve the integral of the answer you just got from the previous interval. So what we just not previous interval, oh my god, previous step. What is wrong with me? Previous step. Got integrals on my mind. But anyway, sorry about that. That was a typo. But yeah, solve the integral of the answer you just got from the previous step. So from the previous step, we just got that we got negative 1 times the integral of u to the 8th minus 3u to the 10th plus 3u to the 12th minus u to the 14th du. Let's just kind of ignore this negative 1 until the very end, and let's just kind of put the rest in parentheses. So negative 1 times the integral of u to the 8th minus 3u to the 10th plus 3u to the, why does the minus sign look sideways? Plus 3u to the 12th minus u to the 14th du. Anyway, that would be negative 1 times u to the 9th over 9 minus 3u to the 11th over 11 plus 3u to the 13th over 13 minus u to the 15th over 15, and then plus c. But then the plus c doesn't get the times negative 1, so then you can kind of put the plus c here, because the plus c isn't going to get the times negative 1 thing, but yeah, whatever. Anyway, so let's just distribute that negative 1 out. So we're going to get negative u to the 9th over 9 plus 3u to the 11th over 11 minus 3u to the 13th over 13 plus u to the 15th over 15 plus C. All right, so that's what we got for step 8. All right, so for step 9, we're going to take the answer from step 8, which is this answer, and we're going to replace u with cosine x. So everywhere we see u, we're going to see cosine x, and then that's the answer. Let me actually write that. Well, I'll write that at the end. Anyway, let's just keep going. So anyway, so we're going to take the answer from step 8 and replace u with cosine x. Then we'll be done with the answer. Done with the problem, essentially. So yeah. So like we said, we had negative u to the 9th over 9 plus 3u to the 11th over 11 minus 3u to the 13th over 13 plus u to the 15th over 15 plus c. We're going to take cosine x and replace that every time we see u. So anyway, since u is equal to cosine x, so we would get, when we replace cosine x with all the u's, we would get negative cosine x to the 9th over 9 plus 3 cosine x to the 11th over 11 minus 3 cosine x to the 13th over 13 plus cosine x to the 15th over 15. I kind of ran out of space. Let me put this at the bottom. Plus c. So then this would be the answer. So then let me write this in red and like kind of fancily squiggly this out really quick. And so yeah, so then this is the answer to the integral. Let me put a little smiley face since we're done. Yay! Aren't smiley faces always fun? Yeah, so then that's the answer to the integral. When I'm done with stuff, I always like to finish things out with like a conclusion. So in conclusion, we can conclude that the integral of sine x to the 7th, let me write that 7 better, sine x to the 7th, times cosine x to the 8th, dx is equal to negative cosine x to the 9th over 9 plus 3 cosine x to the 11th over 11 minus 3 cosine x to the 13th over 13 plus cosine x to the 15th over 15 plus c. So that's the answer. All right. I did a second example as well, example 2. For scenario 1, I did another example, example 2. It's the integral of sine x to the 3rd power times cosine x to the 4th power dx. As you can see, m, which is the exponent of the sine function, it's 3, and that's odd. And then n, which is the exponent of the cosine function, is 4, and 4 is even. So yeah, I'm also gonna upload this to Google Drive, and it'll also be available in the link in the description as well. So yeah, here's just another second example. All of the things are like done out for you and stuff like that, just for you to follow along and to show a second example of scenario 1. All right, guys, so that pretty much sums up this topic, and I will see you guys in the next video. Thank you.
I could cry for